In this video, we're going to focus on evaluating trigonometric functions of special angles. So first, let's talk about the relationship between special angles and the unit circle. Okay, remember the unit circle is a circle graphed in the Cartesian plane where the radius is 1 unit, hence it's called the unit circle. And then its center is situated at the origin of the Cartesian plane. Okay. Here we can see angles in standard position. All right, standard position again, the vertex is at the origin and then the initial side is at the positive x-axis, right? So origin, the vertex, and then the initial side here. So the initial side intersects with the unit circle and the intersection generates an ordered pair, all right? And that's 1, 0. 1 is the x component, 0 is the y component. Okay, and each of the terminal sides of the special angles intersect with the unit circle, again produces or generates specific ordered pairs. Okay, for instance, we have the terminal side of 30 degrees intersects with the unit circle, and that will give us this ordered pair, square root of 3 over 2, 1/2. Doing the same with the other special angles will generate the rest of the ordered pairs that we can see here. Okay, now let's talk about how to determine the values of the trigonometric functions. Okay, in order to do that, first let's take this for instance, this 30-degree angle which is in standard position. Okay, and then from this point, the intersection between the terminal side and the unit circle, from this point let's draw a vertical line going from this point to the positive x-axis. Doing this will generate a right triangle. Okay, let's take this right triangle out. Okay, right triangle. This angle here is 30 degrees. The length of the hypotenuse is equal to the radius of the circle. This is the unit circle, therefore the radius is 1 unit. Okay, and then the length of this side and this side. For this side, the length of this side is equivalent to the y component of the ordered pair, right? This is the y component of the ordered pair. And the y component in this case is 1/2. So this is 1/2. This side here, the base of the right triangle is, or the length of this side is equal to the x component of the ordered pair. So that's square root of 3 over 2, right? So first, let's determine the value of the sine function of 30 degrees. So that would be sine of 30 degrees. All right, and the sine function is defined as the ratio between the opposite side, okay, in this case 1/2, divided by the hypotenuse, which is 1. All right, therefore sine of 30 degrees is 1/2, which is the y component of the ordered pair. Okay, how about cosine of 30 degrees? So cosine of 30 degrees, this is the ratio between the adjacent side, in this case square root of 3 over 2, divided by the hypotenuse, which is 1. All right, and so the value of the cosine of 30 degrees is square root of 3 over 2, which is the x component of the ordered pair. All right, if you can notice, the denominator is always 1. This is because the radius of the unit circle, of course, is 1, right? Therefore, we can just say that the value of the sine function of any special angle, okay, is equal to the y component. Remember that the ordered pairs are written in the form xy. Okay, so again, we can just summarize the value, all the values of the sine function of the special angles as the y component. of the ordered pair. And then the value of the cosine of any special angle is whatever the value of the x component of the ordered pair. Alright, so let's say cosine of 60 degrees, then the value is the x component of the ordered pair, which is 1/2. Alright, sine of 60 degrees, on the other hand, is the y component of the ordered pair, which is square root of 3 over 2. Okay, and then for the rest of the trigonometric functions, the tangent function, and then the reciprocal trigo functions, we have the cotangent, secant, and cosecant will just follow. Alright, just remember that cosine corresponds to the x component and the sine function corresponds to the y component of the ordered pair. Knowing this concept will be very helpful, especially if we're not allowed to use calculators, for instance, during exams, so on and so forth. Okay, hence, this necessitates that we at least familiarize the unit circle, or you can memorize the entire unit circle if you can, and if you want. Alright, or you can just memorize the first quadrant, okay, and then the rest can be obtained through the use of symmetry. Alright, and then we have some other techniques. We can draw right triangles, the 30, 60, 90 triangle, or the 45, 45, 90 triangle, whichever is applicable. We also have a method that involves using our fingers to form patterns that correspond to values of the trigonometric functions of special angles. Now let's move on to evaluating trigonometric functions still, but using reference angles. Okay, remember that for an angle in standard position, for every angle in standard position, there is a corresponding reference angle. For instance, we have here an angle in standard position. This is the initial side, okay? And then, for instance, this is where the terminal side is situated. Then this is our angle in standard position. Let's call it theta. The reference angle in this case is the angle between the terminal side and the negative x-axis. Okay, remember that reference angles are always positive acute angles. Okay, let's call it alpha. And so the value of the trigonometric function of any special angle in standard position is actually equal to the value of the trigonometric function of the reference angle. However, depending on where the terminal side is situated, it can be positive or negative according to these relationships. Sine of angle theta, which is in standard position, is equal to plus minus or positive negative the sine function of the reference angle. It's either positive or negative. This depends on where the terminal side is situated, whether it's in the first quadrant, second quadrant, third quadrant, or fourth quadrant. Remember that the sine function corresponds to the y component. So it's positive above the x-axis, it's negative below the x-axis, right? For cosine functions, on the other hand, remember that the value of the cosine function of any angle in standard position is or corresponds to the x component of the ordered pair in the unit circle, right? And x can be positive or negative. X is positive on the right hand side of or to the right of the y-axis, and it's negative to the left of the y-axis. Okay, so we can summarize the signs. Let's say we consider only the positive trigo function values. So in the first quadrant, all trigonometric functions or the values of the trigonometric functions are positive, okay? Because both the x and the y components are positive, okay? On the second quadrant, the only positive trigo function values are for the sine function and its reciprocal, sine and cosecant, okay? Because in this case, the x component is negative, only the y component is positive. On the third quadrant, both the x component and the y component is negative. Therefore, the only positive trigonometric functions are tangent and its reciprocal, which is cotangent. Okay, remember the tangent is the ratio between uh, the sine value and the cosine value. Okay, so if sine is negative, cosine is negative, then the ratio is positive. Okay, and lastly, on the fourth quadrant, only the x component is positive. Therefore, the only positive trigonometric function in this case is the cosine function and its reciprocal, which is the secant function. Okay. If you're familiar with the mnemonic, add sugar to coffee, or all students take calculus, then this is what those mnemonics pertain to. Okay, the positive trigonometric function values for each of the quadrants in the Cartesian plane. Let's take, for instance, 150 degrees in standard position. So we have here the vertex, the initial side, and then the terminal side. Okay, this is theta equals 150 degrees. The reference angle is this acute angle here formed between the terminal side and the negative x-axis, and that is equal to this is 180, right? 180 minus 150, so this is 30 degrees. All right, therefore, let's say we take the sine function, we evaluate the sine function of 150 degrees. So sine of 150 degrees is equal to sine of the reference angle, which is 30 degrees in this case. Okay. Now, how about the sine? The terminal side in this case is situated at the second quadrant. Okay. And at the second quadrant, only the sine function is positive because the y component is positive and the x component is negative. Therefore, the value of sine of 30 degrees is positive. Okay. How about cosine? So cosine of 150 degrees is equal to cosine of the reference angle, again 30 degrees. The sine, however, again, the terminal side is in the second quadrant, and in the second quadrant, the x component is negative, where the x component corresponds to the cosine function value. Okay, therefore, this is negative, which can also be verified using this technique here, or this mnemonic here. Okay. Now let's try some examples. We have here, find the value of cosine of 600 degrees. Okay. First step, let's try to find the reference angle of 600 degrees. Okay. So let's say we have here a Cartesian plane. This is the y-axis. This is the x-axis. 600 degrees in standard position. This is the vertex, initial side. Now, 600 degrees is more than one revolution because one revolution is just 360 degrees, right? So let's draw one revolution. This is one revolution, right? 360 degrees. If we go all the way through here in this, in the positive y-axis, plus 90 degrees. So 360 plus 90, that would be 450 degrees. Okay, so at this point, we get 450 degrees. If we add another 90 degrees from the positive, going from the positive y-axis to the negative x-axis, then that's 450 plus 90. This is 540 degrees, right? And then another 90 degrees. So that's 540 plus 90. We'll get 630 degrees. Okay? and this is now more than 600 degrees. Therefore, 600 degrees, the terminal side of 600 degrees is situated between 540 degrees and 630, which is here in the third quadrant. Okay, so roughly here. So we can end here. This is our angle in standard position, positive 600 degrees. Okay, remember at this point we have 500 and 540 degrees. Okay, after one revolution. And so the reference angle, let's call it angle alpha here, is the difference between 600 and 540, right? So 600 minus 540, and that is equal to 60 degrees. Okay, and so cosine of 600 degrees is equal to cosine of the reference angle, which is 60 degrees. How about the sine? Now, the terminal side is in the third quadrant. Okay, if you remember the mnemonic, add sugar to coffee, at the third quadrant, only the tangent function and its reciprocal, which is the cotangent function, are positive in value. Sine is negative, cosine is negative. That is because uh, the x component and the y components are negative in this case. Okay, therefore, the cosine value at this quadrant is negative. So we put negative sign. Okay. Now the next thing we need to do is to evaluate cosine of 60. Okay. So we now have cosine of 600 degrees equals negative cosine of 60. Cosine of 60, going back to the unit circle, this is the x component of the intersection between of the ordered pair, which is generated from the intersection between the terminal side of 60 degrees in standard position and the unit circle, right? And it's equivalent to 1/2. Therefore, cosine of 600 degrees is negative 1/2. All right. Next, let's determine the value of tangent of negative pi over 3. Okay. So Cartesian plane, y-axis, x-axis, the vertex. We have here a negative angle, so the rotation should be clockwise, right, from the initial side. We have here negative pi over 3. Pi over 3 is between 0 and pi over 2. Okay, in this case, because we are rotating clockwise, this is 0, the initial side, and pi over 2, in this case, is the negative y-axis, right? Again, because we are rotating clockwise, right? Therefore, negative pi over 3, the terminal side of negative pi over 3 is situated here in the fourth quadrant. Okay, so that's negative pi over 3. So theta equals negative pi over 3. All right, and then the reference angle is the acute angle formed by the terminal side here and the positive x-axis. So this angle here, which is just the same as angle theta. However, remember that reference angles are always positive. So just take out the negative sign. Okay. Therefore, tangent of negative pi over 3 is equal to tangent of positive pi over 3. Okay. The sign in this case, the terminal side is situated in the fourth quadrant. In the fourth quadrant, the only positive trigo function values are cosine and its reciprocal, which is secant. Okay. Tangent is negative because remember it's the ratio between sine and cosine. Sine corresponds to the y component, cosine corresponds to the x component. So in this case, the x component is positive, however, the y component is negative. Therefore, the ratio between x and y, or y and x, is negative. This is negative. Okay. And so we have tangent of negative pi over 3 equals negative the value of tangent of pi over 3. Okay. Again, tangent is the ratio between sine and cosine, where sine corresponds to the y component of the ordered pair, right? And it's equal to square root of 3 over 2. On the other hand, cosine, the x component, this is equal to 1/2. Alright? Therefore, tangent of negative pi over 3 is equal to negative. So we can simplify this as square root of 3. Okay.